Čaute. Haló? Počuť? Dobre, super. Okay, so I will switch to English if that's okay for you. Okay, so today I will talk about the production-grade cloud application checklist, which means like these are the things that you should care about when you are trying to deploy or basically develop an application for basically for today's world, because I don't believe like we have any other than cloud applications anymore. About me, so I was a full stack developer, and I also worked as a cloud architect in the past, and I've been developing applications in the cloud for almost like 10 years, mostly on AWS. And currently, I'm a CEO of a startup called StackTape, and we help teams to develop and run cloud applications on AWS. We basically created a platform that makes the AWS developer friendly. Okay, so what does the production ready mean? It's obviously it is different for different types of applications. So yeah, for example, for a hobby project, it's perfectly fine to have something that doesn't scale or is not very reliable. But if you have like some very like critical systems, for example, for banking, then that changes. And I will try to tell you like what are the minimum capabilities that your applications should have to be considered production ready, and also like come through or try to explain like what are the things that you should care about when you have like some very critical application. And yeah, also like what does cloud mean? By cloud, I mean mostly containerized applications that is able to run on ephemeral containers, which is like short-lived containers. For example, like what I don't consider to be cloud is like if you purchase something like a VM from I don't know, something like Hetzner or something, and then you SSH to the VM, and then you just git pull to the and then spin up kill the previous process and spin up the new process to deploy your applications. I don't consider this to be cloud, because it's you still have like, even though you're not running your own hardware, but you're still subject to all these different kinds of issues that come with having only a single instance of your application running. Okay, so so first I will talk about like what your application's code needs to do, or how it needs to be architected and designed. So the most important part is that it should be ephemeral, or it should be able to run on ephemeral instances, which means that if it receives something like process like if it receives like something like SIGINT, or like the process or the signal that signalizes that it should end, then it should gracefully end, which means that it closes all of its connections. For example, the database connections, it handles all the requests, and then it shuts down gracefully. And yeah, this also means that your application should be able to run like in multiple, or you should be able to run multiple instances of your application that are load balanced. And so you, for example, shouldn't be able to, or yeah, I don't know how to say so. So yeah, basically you don't need to use or you can't use in-memory session data, because for example, when one request arrives to your server, for example, when it gets load balanced, for example, to a instance 2 out of 10, but the next server might be a load balance to instance 4 out of 10. So you can't assume that it will always come to the same server. So yeah, you should store your session data, for example, in Redis or some like other kind of storage. Yeah, then we should talk about source code builds. So when we are talking about containers applications, so these applications are mostly Dockerized for like for OCI, as an OCI image. And yes, these builds should be automated, scripted, which means like you shouldn't have something like 8 steps process in your README that tells you like how to build the container. It should be automatic, so basically just a simple script. There are like multiple options like that you can use for it to build automatically. For example, you can use like something like Packito build packs or Nix packs, which are basically tools that scan your source code and create like a runnable OCI compliant image that you can then run in the cloud. But yeah, also like if you want to run your function, or if you want to run your code as a Lambda function, then this is more difficult, and you should care about like how to package your Lambda functions yourself with all of their dependencies, and how to upload them to basically S3 or something like this. Yeah. So then we should care about like deployment artifact management. What I mean by this is like this is the storage that stores your your deployment artifacts, which are in case of application running in a container, these are the Docker images, and in case of running your code in Lambda, these are the S3 like the deployment artifacts, which are like zips with all of your source code and all of its dependencies. Yeah, you should also choose your infrastructure provider. So yeah, there are the big clouds, or the big three like AWS and Azure and GCP, but then you have also like a lot of other choices. For example, in terms of like a platform as a service providers, which are less, they have less capabilities, but they are also like way less like complex to use. Yeah, or you can even use like backend as a service, and it's up to you to choose the right amount of abstraction. Yeah. So then let's talk about infrastructure provisioning. So yeah, your application should be you should be able to repeatable deploy or provision your infrastructure. What does that mean is that if it's not like only like I go to like AWS console and click around and spin up everything that I need for one instance of my application, but I should codify it inside something like AWS CloudFormation or Terraform to be able to spin it up again if I need to deploy another environment. And this also improves the auditability, and also it's reviewable if you handle this in a source code or in something like Git. Then you are able to review it and then do code reviews, and you see like when something broke and how to fix it. So basically, click ops, which is the weight of just clicking around and spinning everything in some UI. It's not ideal, and if you do it, it might work for like smaller applications, but it won't work for like a larger or more complex applications. So yeah, then let's talk about service deployments and orchestration. So yeah, these are things like what I mean by this is these are tools like Docker Compose or Docker Swarm or like AWS ECAs or even Kubernetes. So these are basically the tools that run your application code, and also these tools help you to deliver your application code or basically to run it on the server, which means like they do things like health checks. They help you to do things like rollbacks, and also like as I mentioned, they also deploy your application code. And so yeah, if you want to make your application production ready, then you should talk about like what deployment strategies do I need to use? For example, like is it okay if I have like some small amount of downtime when I try to deploy the new version of my application? If that's the case, then it's very simple. You don't need to use anything special, but you most likely should be able to at least deploy your application on a rolling basis, which means like you will have, when you are deploying the new version, you will have one standby version, and only when the new version is ready, then the traffic will change to the new instance. But also you can do things like blue-green deployments or canary deployments, which basically run multiple instances of your application, and they gradually change the load that come to your application. And if something goes wrong, so for example, if your API starts throwing some like 500 codes, HTTP codes, then it will just roll back to the previous version automatically. And this way, it ensures that when you deploy some bug or anything to production, that it will automatically roll back, and also it won't affect many users, only a small portion. And we should also talk about circuit breakers, which is basically sometimes when you are deploying your application, and for some reason the application fails to start. For example, it's missing some like environment variable, and it throws an error, which means it exits the process with a non-zero code, so it fails. Then the circuit breaker or when you have, for example, like self-healing container orchestration, this means that the orchestrator will try to restart it again and again, but the code will keep throwing the same error, and if it throws the error for some arbitrary amount of times, then the circuit breaker will be triggered, and the applications and the deployment will fail. If you have ever worked with AWS ECS, this is a very common mistake, and it's a kind of a nightmare to work with this, because if your application or if your deployment or application has an error in it, then we'll just wait 3 hours, and then eventually you won't even see the error, because the infrastructure or the logs from the infrastructure that would tell you that there was a bug, they are rolled back, and you won't see them basically. But there are strategies to fix that. Also, you should think about load balancing. So there are multiple options there. For example, like mostly these are you can use application load balancer, and it works on the L7 of the OCI model, and it allows you to, for example, route requests based on the HTTP headers and HTTP paths and things like this. Or you can use a network load balancer, which allows you to route requests based on the IP and other network characteristics. The network load balancer is in general way faster, but it's not as convenient to use it. And also you can, for example, on AWS, you can also use API gateway, which is a way to route your request as well. And for example, you can also use HTTP API gateway on AWS to route requests to your containers, and it's less expensive, and it's also like a serverless way to load balance your applications, which means like you don't have to pay for the load balancer. This is always available, and you're paying like hourly fees for them. But it has a disadvantage that it only works with HTTPI requests, and you, for example, can't use like WebSockets with HTTP gateway. Also, I wanted to mention something else regarding load balancing, and these are the strategies that these load balancers employ to distribute traffic to multiple different instances. So for example, in most cases we are using round robin, which is basically the strategy that distributes the traffic evenly, or tries to distribute it evenly by sending one request to instance A, one to instance B, and one to instance C. But this in some cases is not sufficient, because these requests might not take like equally long to handle, and then we need to employ some other strategies. For example, like based on the load or like the CPU and the memory usage of these different containers, or the downstream resources that you are using. So this is just something to think about, and probably for most applications you will be okay just using HTTP API gateway and round robin, but for the more complex ones you should think about using something else. And also for those applications that require a lot of performance, then you should also consider using network load balancer. Now we should talk about scaling. It's very important to think about how fast my applications need to scale when the traffic or when the load changes. So, for example, if it's just like very gradual, if the traffic only increases very gradually, then you might be able to just see it, and then just come to your PC and just basically deploy it again with more resources. But in most cases, we probably want to be able to scale automatically based on the load. for example, on CPU and memory usage of your containers. But this also means that we should this kind of scaling most commonly happens like horizontally by adding more instances of the same application. And as I mentioned, like if you want to scale horizontally, then you need to have load balancer or API gateway employed. And you should also think about having or scaling about your other parts of your infrastructure, for example, databases, not only your own like containers that run your applications code. And so if we are using databases or other such infrastructure components, then we should think about scaling their resources like a CPU and memory, also storage, and for example, we can also horizontally scale our database by adding read replicas or using something like cluster databases that basically can add these additional read replicas automatically. For example, these are the tools such as AWS Aurora Serverless that can do this very efficiently. So that's something you should think about. And in some cases, it's okay when you scale just based on the CPU and memory usage of your application or of the resource that you want to scale. But sometimes you should also think about whether you should not scale it based on for example, based on the amount of traffic that comes to your application and stuff like this. Then another thing that you should think about is high availability and fault tolerance of your application. This means that you shouldn't have like only a single source of truth or single source of your data, and you should use data replication. So, for example, if I have my database in data center, for example, in something like Frankfurt, where the AWS has the data centers, AWS, for example, has multiple different regions where they have their data centers, but even in every region they have usually 3 different local regions, and and they call them availability zones. So, for example, it's a good idea to have at least one. If I have my database on AWS, then it's very good to have something like I'm using one availability zone, and I should also have my database in the other availability zone. And if something happens to the availability zone 1, then AWS will automatically route your traffic to the availability zone 2. You should also have automated backups of your database. For example, in AWS, it's very easy to configure it to do the backups. For example, every hour or every day, so you don't lose your data. Or if you screw up something like a database migration and you delete some data, then you will be able to roll it back. I've already talked about the multi-zone deployments, and you should have like automatic failover configured, which means that if one database stops responding, then the other standby instance is used. Also, some databases also are able to do the point-in-time recovery, which means like you can roll back the database to exact point in time, and in case you screwed up something or your data gets corrupted. And if you have like if you need something like 9 nines of availability, then you should also think about having like multi-region deployments. So, for example, if I have one data center in EU Frankfurt, but then I will also have some data center in US in case something like whole Europe gets cut out of electricity or something, then we will be able to move forward. The next thing that you should think about is security. A lot of these things are handled automatically for you if you use modern cloud provider. For example, like operating system level security and automatic patching of the underlying system. So, for example, these are things like patches to the Linux kernel or something. But also, if you are using managed database, for example, such as AWS RDS, then also they will automatically patch the minor versions of your database, so that you don't get like vulnerabilities hanging there. You should also use secrets for your for things like database credentials. You shouldn't store them as plain text, obviously, and yeah, for this you can use something like AWS Secrets Manager or like the HashiCorp Vault, or there are managed services, or you can manage your services on your own, but never store them in files and commit them to Git. You should also think about having firewalls if you want your applications to be production grade, because yeah, there are a lot of different exploits that they're trying to basically. There are some bots that are just basically periodically scanning the internet and trying to and they're basically sending requests to every site that they see, and they are trying to sniff out if there's some kind of vulnerability, and if the vulnerability is there, then they will basically perform the attack and try to steal your data from your database or something. But these most common exploits can be mitigated by having these firewalls, because they have some rules that can automatically detect that this is a bot and he's trying to sniff out like some vulnerability, and it will automatically deny those requests. And in some cases it can also protect you from DDoS attacks. And if you're using something like AWS or some like bigger cloud provider, then you should also think about having these cloud providers always have IAM, which is identity and access management, but configuring this is very complicated. Because you need to grant permissions, even like if you want to communicate from a resource A. So, for example, from my container with some database, then yeah, I need to grant my container the permission to talk to the database. And in a lot of cases, since this is very complicated to do and it's very easy to screw it up, then people basically give the full permissions to everything, and yeah, but that's not very secure. But so yeah, you should also think about having the least privileged permissions for every resource. So, for example, I will only have the permissions that I need to perform my task, and none other. And also, this also applies to having when you have like different users, or like people that interact with your AWS account or with your cloud provider's account. Then they should only have the permissions that they need to perform their task, and none other. Then let's look about logging. So yeah, you should aggregate your logs to a central location. You shouldn't have them only on your server in some something like log file that you, and then searching them just by SSHing to your container and seeing them. That's not very convenient, and it's also like very easy to lose them if something goes wrong with the disk on your instance. And and if you have aggregated, then you should also have some software that will make it easy to search them and query them and see if there's something that's interesting for you. And as I mentioned, the storage of your logs should be high availability, so that you don't lose them. So it's not very good to only have them something like one disk. But yeah, in most cases, it's best to use these managed log storage or logging providers, such as AWS CloudWatch, or like have something like Elk Stack. And you you shouldn't try to basically replicate what they do on your own, because it's more complex than it looks at first sight. Then we can talk about monitoring. Monitoring is basically seeing like how our applications perform, or how our infrastructure performs. So we can see like if it's available. So for example, we can periodically send requests to our to our services and see if there's some downtime. Then we should also collect application metrics, which means that we can see how we can see the memory usage or CPU usage of our system, and based on that we can also scale. So if we don't collect this data, then we can't scale. And yeah, we can also collect some metrics related to your application. So for example, like amount of requests that it handled, or I don't know, maybe some like business metric that you need to track. And for example, you can also scale based on that business metric or something. You should also have automatic alerts set up, so you know like if there's something going on with your applications. A lot of times, for example, this can be something like you are facing some like DDoS attack, and for example, if your application is scalable, then yeah, it will continue working, but your bill can go to tens of thousands in just one night or something. So that yeah, you should be you should have some alert to know like when that's happening. And also for more complex applications, or when you are using microservice architecture, then you should also probably have something like distributed tracing. So for example, if my request or the user it needs to go through many different services to be successfully handled, then I should know that I should add something like correlation ID to the request, and I should be able to track it, like how it went through the infrastructure and how it went back. And if something bad happened, I should be able to identify like when it happened and why it happened, and what had happened on the previous step and what happened on the next step and stuff like this. A very important thing that a lot of people forget when they are setting up their infrastructure is that it should be well documented. Because I've seen things like, well, Miro is not in work, so yeah, we can't deploy anything, or we don't know like how something works, or he left 2 months ago, so yeah, nobody can touch the infrastructure, or it will explode. So we should also always have documentation for the infrastructure. And yeah, we should have like high-level overview of what's happening, and yeah, how we can replicate it. This is also something that I mentioned before, because that you should have. For example, like if I want to deploy another instance or like environment of my application, it should be easy to do, and I should know how to do it. And also like the other developer that we hire next month should be able to come and basically deploy his or her environment. And also we should have something like troubleshooting. So the most common problems that developers or people interact with your infrastructure have should be well documented, so that people don't waste their whole day trying to fix some issue that somebody else has faced in the past. And yeah, we can. If I don't know how much time we have, but yeah, we can talk about cost efficiency. Okay, it's very important to it's not for every applications, but a lot of times it's very important to think about costs upfront, especially when we have a lot of load. So yeah, it's very important to have overview of all the resources that we are using, because it's very common, for example, in AWS accounts that in the bigger organizations, that something like 80% of the services or the resources that are deployed are something like zombies that somebody once deployed, then forget about it, but nobody nobody can delete it because they think that somebody else is using it, but nobody knows like whose server is this. And so we have a lot of, we should always have like a detailed overview who's owning what, and when should it, and if it's no longer needed, then we should delete it. We should already have budgets and alerts. So for example, you can have alerts for certain stacks, which means like, for example, I can get notified when the spend for some applications goes over, for example, like 500 a month, and this can prevent things like having like a surprise bills that go overnight. You should also right-size your application, which means like if you have like steady load, then you should basically probably you can notice that upfront like how much resources you need, and so that you don't need to overpay for it. And if you have horizontal scalability set up, then even if something bad happens, then it's not a problem if more load comes in. You should also think about having or about using serverless applications or serverless functions, for example, because a lot of times when there are like when the applications have spiky traffic, which means like, for example, like let's say like we or something like bistro.sk, and there are a lot of people that are ordering food around lunchtime, then at that point it can your application can quickly go from like, I don't know, like something like 1,000 requests per second to, I don't know, 20,000, and for example, trying to accommodate this traffic by something that is not scalable, that is not very efficient. And also, like in the night, probably not a lot of people are ordering food. So basically, if you're using something like Lambda functions, then it can scale to 0, and it can save you a lot of costs, even though the price per one compute unit is usually way higher if you use these serverless application or serverless services. Another tactic that you can use to reduce costs is to use reserved capacity. So, for example, if you tell AWS that I will rent this VM for, I don't know, for example, 3 years, person discount and stuff like this. And the most interesting thing is using spot instances. The spot instances, for those of you that don't know, like these are the instances. So, for example, AWS has some idle capacity that nobody is using. And they can rent you this capacity for containers or VMs for way lower costs. But these spot instances work in a way that AWS can at any point tell you that it needs the capacity back. So your applications should be able to, when they receive something like SIGINT or some kill signal or I don't know what, then you should be able to stop everything that you're doing and give it back. Again, as I mentioned, like close the database connections. But at this point, the containers that are already running might not be sufficient to handle all the traffic that you have. So then you should be able to just to rent the normal instances, not spot instances, to accommodate all the traffic. And setting this up is complicated, and but it's possible. And from my experience, the companies, even in Slovakia, that have a lot of traffic and are using AWS, are using this strategy to save a lot of costs, because these spot instances can be like even like 90% cheaper than just renting the normal instances. The normal, I mean, on-demand instances. So this is something that you should think about. But as I mentioned, it's not very easy to set up, but it can have a very good results. And the last thing that I wanted to mention is that you should also think about the developer experience, because if your developers are developing something new and they need to, for example, create a new microservice, or they need to create something like S3 bucket for certain reports or something, or they need to add a new SQ, for example, to communicate between different services, then it shouldn't take 2 weeks for some DevOps guy to do it for them. And it's always nice when they can do it on their own. And so they should be able to quickly provision something, and also and this allows them to have fast feedback loop. And also if you're developing cloud applications, then a lot of cases you are interacting with a lot of different cloud services that you basically can't replicate locally. And this makes it very hard to even like develop and even debug some of these applications. So yeah, you should think about having or about how you can run your application in a development mode, which has fast iteration times, and these developers can easily or quickly or efficiently develop their applications. Also, like if you have if you have like multiple environments, like production or development or testing or staging environments, they should have like development and production parity as much as possible. So for example, the only thing that should change is the size of the instances that you're using, and basically nothing else. And as I mentioned, it's always nice if everything is deployable by developers. Okay, so this might have sounded too complicated. It also, like, if you want to have like really production-grade like cloud application, then it's a lot of work, and you need to have a lot of knowledge. And yeah, I was at this situation like some time ago, and yeah, as Daniel mentioned, I'm working for a startup called StackTape, where we are basically trying to automate all this and make it easier and seamless. And yeah, so if that's okay for you, I can show you, for example, a quick demo of what we do. We're basically trying to make AWS developer friendly and easy to use. And yeah, for example, if I want to, let's say I wanted to deploy some new applications. So this is our StackTape console. This is, for example, for us something like our development account. And let's say I wanted to deploy, I don't know, like a new application. Let's say I want to deploy it using Git, or I want to deploy it from Git. So I will just choose project name. I don't know, some test something. I will choose a repository that I want to deploy, and then I have my project created. I can create a new stage. So for example, I choose a branch. Okay, there wasn't any branch available. But sorry for that. We can deploy another thing. I wanted to show you like how easy it is to deploy, or how easy it is to configure something in StackTape. So for example, imagine like I wanted to deploy something like web API that has that also needs to have like Postgres database and like something like Redis. Then I can select a preset. And yeah, then I will get this. This is basically all the configuration needed for this to run, and then I can just configure some parts of it. So for example, the packaging of the application, how the applications is built. I will just use some dummy values. I will just select like I don't know, some 1 CPU, 2 gigs of RAM. And I will configure password, something. Then configure RDS instance, and then Redis at last. And yeah. Okay, and as we can see, like here at the bottom, we have it's already calculating like how much everything will cost. And everything that you see here we translate it to AWS CloudFormation template. And for example, this CloudFormation template would have something like 2,000 lines of CloudFormation configuration. And yeah, with StackTape, it's as simple as this. And then when I click to continue, then yeah, I will just deploy everything. And so yeah, that's basically what we do. And if you're interested, I will be happy to talk about it to you some more. And yeah, if you want to develop applications or AWS, yeah, feel free to reach out. Yeah, thank you. So that's now there's time for your questions. WebUP, takto? Jasné. WebUP, takto? Dobre. WebUP. Okay. Huh? How soon should I start with Terraform or a similar tool when I'm going to cloud? Asked by Srigi. I believe he knows that. Yeah, it's hard to tell because sometimes nowadays there are tools or platform as a service tools or even things like StackTape that basically allow you to deploy your applications very easily and even repeatably without learning very complicated tools such as Terraform or AWS CloudFormation. But if you, for some reason, can't use them, then I believe you should, or if you want to be a DevOps expert, then you should definitely learn them right now, or start learning them immediately, because I don't believe like anything that you configure using ClickOps tactics, which is basically just going through these AWS consoles or cloud provider consoles, will be sufficient. But be ready to. It's a long journey. It's not easy, and also like it has like very long feedback cycle. So, for example, if you misconfigure something, then you try to deploy it, then you get back some very cryptic error message, and it's very hard to just learn it. It just takes time. So I can compare it. For example, I was a developer. I was using backend development. I was learning some things like React, and learning infrastructure, and not only the tools, something like Terraform or AWS CloudFormation, but even just understanding all these different concepts like networking and IP tables and stuff like this. It was like, I don't know, maybe like 20 times more complicated than learning something like React. It's like way more complex. And also it's not fun because when you're developing or when you're creating applications, then it's sort of fun because you're constantly building something new and iterating on it. But if you're configuring something that nothing will nothing new or innovative will come out of it. It's just configuration, and so it's boring. PHP or JS? Or sorry, how is your experience with canary deployment strategy with microservices and one shared communication resource like message broker, like RabbitMQ and Kafka? Well, first I should tell you that I'm not a very huge fan of microservices. I mean, they definitely have their use cases, but I believe like a lot of times it would be way easier to just not use them and not go the extra mile to configure everything. But when you're already using them, then I believe like this is the best strategy, using message brokers or to communicate between these services, because different services can have different loads, and for example, one service could be able to, or is able to handle more requests, and then it will flood the other. And so it's great to have something like a message broker between them that basically throttle the request and send them gradually so that you don't flood the other service. So that's definitely a great choice. I can't really tell you some meaningful alternatives. So but it's perfectly fine to do something like this. PHP or JS? I mean, I'm a huge TypeScript fanboy, and but use whatever you like. I won't tell you that the PHP is a shitty language. In the end, like it's a lot of great applications were developed in it, and I like the like you can prototype things very fast using it. So definitely go for it. It's not my first choice, and also like the architects would tell you like, don't use it. It's a shitty language, but when it works for your use case, then it's perfectly fine to use it. What strategy or tool for log aggregation would you recommend from your experience? Is it possible to connect it with monitoring and do 2-in-1? Well, a lot of people are using Elk Stack, which is like Elastic, Logstash, and Kibana, and I believe like you are able to do everything in there. But there's this database, like there's this new analytical database, and I can't remember how it's called, but I believe like it was created just for such kind of use cases, and the tools that are developed on top of it are very good. And one I can recommend you one tool. It's also it's a startup from Czechia, but it's their CEO is Slovak, and they're called Better Stack. So definitely check them out. Their stack, I believe you will be able to do everything. And yeah, it's very fast. It's a very good piece of technology. So yeah, just go check them out, definitely. What are the tools you mentioned to automatically scan the code and prepare the build? Yeah, so it's a Paketo, Paketo.io. This is one tool, and the other one is Nix Specs. This one. Yeah, also at StackTape we have our own build packs that are even for Node.js applications. They are even efficient, more like they're the most efficient, I believe, out there. So yeah, if you want, you can also check that. The other question: how would you compare Docker Swarm, Kubernetes, and similar? To be honest, from what I've heard, I've never used Docker Swarm, but people that did, they said like it's that it covers like 99% of what Kubernetes can do, and that it's designed in a way that's less complex, which means like it's way easier to use. And so they all said that yeah, it's a better choice, like in terms of like I would say like capabilities to complexity ratio, that it's better in this regard than Kubernetes. But yeah, Kubernetes has a lot of there's a very large community around it. So and also, yeah, so I would probably use Kubernetes just because of the community, just because it's mainstream, and just because Google's wanted it to win, and they promoted it in such a way that basically everybody started using it, even though it might not have been the best tool at that point. What is the biggest infrastructure you worked with in terms of nodes resources? So in terms of node, so for example, yes, at StackTape we have something like free. Because we have like different services that support everything that we do. We have something like 4 different servers and something like 25 Lambda functions that do one job. And in terms of resources, we've worked with companies where we were trying to set up the cost efficiency or the spot instances in a way that I mentioned, to save time, and they were processing millions of requests per second. So yeah, I would say that the application itself wasn't like complicated in terms of like the complexity, like having like 35 microservices. It was complex in a way that it just had to process a lot of data. What is the biggest? Okay, that was once answered. Is one person able to manage all these best practices and tools? Well, no, but with StackTape, yes. I mean, I was just trying to, we designed this StackTape to be able for you to be able to do this. But if I were to start from scratch, then it's just too much to be able to handle by one person. So yeah, probably not. And also, I should mention that a lot of times it's or a lot of the companies that I worked with, they had something like one DevOps guy or something, and but they also had like backend developers that were doing DevOps. So for example, like, a lot of times, the most senior backend developer does DevOps. So this is something that I've seen a lot of times. So sometimes it's just you don't want to learn it, but then time comes when you just need to do it, and then you need to learn it at that moment. So yeah, what is the difference to OpenShift? OpenShift, I believe, is basically just you can have like your own cloud that you run yourself, but also like you need to manage it and do everything. So yeah, I don't really have experience with it. And comparing it to what? I mean, comparing it to StackTape, then StackTape is a managed service built on top of AWS, and comparing it to other platform as a services, I believe, yeah, you just have a lot more work when you want to, manage OpenShift. But yeah, as I mentioned, I don't have like a lot of experience with it. Okay, so that's it. Thank you.